Recording in progress.
So, okay. So, okay. So what we are talking about is like working with the so we have seen how to work with the strings, right? Okay, I said how to work with the strings. Okay. And next we'll talk about working with the okay, now there is two more data types are there. One is a bytes and one more is a byte array. So what exactly this two data types? So one is called as a bytes. So one is called as a bytes and second one you call it as bytes array. So first we'll talk about what is a bytes is. So this is also one immutable sequence. Okay, bytes is also one immutable sequence. So bytes so bytes is also immutable sequence. So bytes is an immutable sequence data type. Immutable sequence data type. What is bytes here? Bytes is an immutable sequence data type. Then bytes is a collection of, generally bytes is a collection of, the name itself, right? Bytes is a collection of, which one here? Bytes. Okay, it means bytes data type represents, bytes data type or bytes object represents, bytes objects represents one or more than one byte. So this bytes object represents what here? One or more than one byte. Bytes object represents one or more than one byte. And bytes is a collection of bytes, and bytes is an immutable sequence data type. But where exactly these bytes are used? For example, if you want to represent which data, some binary data, you want to represent some binary data. For example, there is one image is there, image. So what is image here? Image is a collection of, what here? Bytes. Suppose you want to read the image, you want to read image and you want to store the image data. So where you store that image data? Into one object. Which object it is? Bytes object. For example, there is an audio file is there. So is it audio file is a collection of what? Bytes. Audio file is a collection of bytes. And you read the content of audio file and where you store the data of this audio file within one object. And what is that object again? Bytes. Okay, so bytes represent which data here? Binary data. Not only that. For example, suppose in networking is there, in networking, how the data will be transported in the network? In the network, data is transported in the form of which one? Bytes. How the data is transported within the network? The data is transported within the network in the form of which one? Bytes. For example, I want to send one message in the network called hello. But hello is what here? String. Hello is a string. But I want this string to be sent to what? Another program. But can I send a string directly to another program? No. I have to convert. I have to convert the string into what here? Bytes. So how you convert? Okay, by using which data type? Bytes data type. Okay, so it is very much useful. This bytes is very much useful in application. This bytes is very much useful in application development, right? This bytes is very much useful in what? Application development, right? So bytes object represents one or more than one byte. Okay, so one byte. So you can represent data in 1 byte format using ASCII. You can represent data in 1 byte format using which one? ASCII. ASCII character set. Or you can represent, okay, in using ASCII. For example, 65 is there. How you represent 65 in byte format? Okay, 65 will take more than 1 byte. So how you represent the 65 into 1 byte? A. So A will take how many bytes here? 1 byte. But 6 and 5 will take how many bytes? 2 bytes. But how can you represent this 65 into byte format? A. For example, if I take B, B is already in which format? Byte format. Okay, but suppose there is 120 user. How can I represent 120 in byte format? By using which encoding standard? ASCII. So how to create a bytes? Okay, a byte. So bytes, okay, bytes is represented. How can you represent bytes here? So bytes is created in different ways. You can create a bytes because bytes is not like a string. We cannot apply all the string operations. Okay, so bytes is there. So how can you represent a byte is? I said. So the byte can be represented. See here. Bytes objects are immutable of single bytes. Now, since many major binary protocols are based on ASCII text encoding, now bytes object several methods that are only valid when working with a ASCII compatible data and closely related with what is a string object. Okay, it's closely related with the string objects. Because I said, like suppose 65 is how you represent 65 in bytes A, but actually A is represented as what? Actually A is represented as what? String. But A is a string, but in this case, is it A is a string or byte? Byte. So byte equivalent of which one? 65. So A is a byte equivalent of which one? 65. 65, right? So now this is one more definition of bytes here. So you can create a bytes in different ways. You can create a bytes in different ways. Okay. You can create the bytes in different ways. So these are different ways of creating the bytes. Bytes object is created. Bytes object is created in, okay, created in what are different ways. Okay, now these are the different ways in which the bytes object is created. The first one is within single quotes. So bytes object is created within. How the bytes object is created within single quotes. Bytes object is created within double quotes. Bytes object is created within triple quotes. So here, how many ways the bytes object is created? Single quotes, but it is prefixed with what here? B. So single quotes, generally, whatever you write in the single quotes, okay, that can be called as which one? String. But this is prefixed with what here? B. So in that case, it doesn't become a some B1 equal to B, and I write here ABs. So what is a B1? B1 is a type of which one? Bytes. For example, if I'm writing some S1 equal to within single quotes ABC, okay, ABC, and if I'm writing type of S1, S1 is which type here? String. S1 is a string, but B1 is what here? Bytes. Okay, so this will represent a buffer, and this you can write inside a binary file, but this cannot be written in binary file because this data type is what here? String. Okay, so string. So you can write in different ways within double quotes. I just write B, it is prefixed with B, and then I said Python and type of B2. B2 is of which type here? Bytes type. So B2 equal to bytes. Now this is also which type here? Bytes type. Okay, and B1 is also of which type here? Bytes type, and B2 is also which type here? Bytes type. Suppose if I'm writing S2 within double quotes, if I'm writing Python. So if I'm writing type of S2, S2 is which type here? String. S2 is a string, right? S2 is a string, but B2 is what here? Bytes. Okay, but I'm saying now this is repeated again. Once we move to the files, binary files, binary files, we'll be talking about again how to work with the bytes. But meanwhile, just try to understand what is a bytes is. Okay. Now you can also create a bytes by using a data type. So B3 equal to bytes of, I want to create a bytes of, I want to create how many bytes here? 10 bytes. I want to create how many bytes here? 10 bytes I want to create. Okay. So if you say print B3, now B3 is created with how many bytes here? 10 bytes. But these are empty bytes. These are what here? Empty. It is created a bytes object with how many bytes here? 10 bytes. But is it these bytes are empty? Yes. These bytes are what here? Empty. Empty bytes are there. How many bytes are there? 10 bytes are there. But all these bytes are in which format? Hexadecimal. So backslash x00 means it is in which format? Hexadecimal format. Backslash x00 means what it is in which format? Hexadecimal format. For example, there is a list is there. Okay, there is a list is there. You have a list with some 65, 66, 67, and 68. So how many integers are there in this list? 4 integers are there. I want to convert this. I want to convert this into what? Bytes. So I want to convert all these 3 integers into what? Bytes. Object. So if I'm trying to say print B4 is having how many bytes? 4 bytes. Now what is the 65 equivalent of byte A? What is 66 equivalent of byte B? What is 67 equivalent of byte C? What is 68 equivalent of byte D? So here we created a byte. If you give only 10, it will create the bytes array with how many bytes here? 10 bytes. But if you want to convert the integers into what here? Bytes. You are converting this integer into a bytes by using a function called which one? Bytes. So these are other ways of. Now bytes is a sequence, and if you want to read it, how can you read it? Using index B4 of 0. Okay, print B4 of 0, comma, B4 of 1, comma, B4 of 2, comma, B4 of which one here? 3. So you are trying to print how many bytes here? 4 bytes. But is it printed in which format? So B4 of 0 means it is printed A or A equivalent of what do you call it as decimal value? Decimal value. That is A equivalent of decimal is 65, 66, 67, and one more is what? 68. So we can read it. How can you read it? With the help of what here? Index. But internally it is stored in which format? 1 byte format. And when you read it, is it read the value as it is or not? Yes. So that is what you mean by encoding and what? Decoding. Encoding and decoding. For example, 65. How 65 is stored in memory? How 65 is stored in memory? Now 65 is converted into what? Binary. Okay. And then it will store in memory. Then how A will be stored in memory? How A will be stored in memory? This A will be converted into what? It will take the equivalent decimal value or not? Yes. So what is the decimal value of A 65? Which is called as which value? ASCII value. It is called as which value? ASCII value. And then this 65 is converted into what? Binary. So this bytes object is work like a buffer. Even application development. Okay. This bytes object also used as a buffer here. In application development, so bytes object is used as a buffer where bytes are stored, where bytes are what here? Stored. In application development, bytes object is used as a, in application development, bytes object is used as an array. Okay, so it is used as a buffer. So where the data will be stored temporarily, right? So because a bytes object is immutable, you cannot do any changes. Because a bytes object is immutable, you cannot do any changes, right? So next one is mutable. Okay, mutable is there, and mutable bytes object is there. And what is that mutable bytes object here is byte array. So bytes array is there. So what is the difference between bytes and bytes array? Only one difference. Bytes is immutable and bytes array is what? Mutable, right? So bytes array represents, okay, represents mutable sequence of which one? Bytes. Bytes array represent mutable sequence of bytes. Means after creating byte array, okay, changes can be what here done. So bytes array support the following mutable methods. What are those methods it will support? Like append is there. Okay, it will support append. It will support which one? Delete. It will support append, delete. Okay, like clear. Okay, clear, pop. Okay, so pop and then remove. Okay, so insert. Okay, these methods. All these mutable methods supported by which one? Bytes array. But is it bytes support these mutable methods? No. Bytes doesn't support these mutable methods, but bytes array support these mutable methods like append, delete, clear, pop, remove, and one more is what? Insert. That is only a difference between bytes and what? Bytes array. So difference between bytes and which one? Bytes array is, okay, where, okay, is, so bytes is an immutable sequence, and bytes array is which sequence here? Mutable sequence. Means after creating bytes array, you can do the changes, but after creating bytes, you cannot do any changes. Then how to create bytes array? So you can create a bytes array in different ways. Okay, you can create a bytes array in different ways here. So you can create a byte array. So byte array in different ways. Okay, so the type is byte. So that is what I've written there. So the name of the type is byte array. Now you can create a byte array in different ways. Now these are the different ways in which you can create it. So byte array is created in different ways. Now these are different ways in which the byte array can be created. Okay, these are the different ways in which byte array can be created. So the first one is creating an empty instance just using byte array. So second one is creating from an iterable of integers. And fourth one is copying binary data from data via the buffer. Buffer is nothing but bytes that is existing byte array or existing bytes. Existing byte array or existing bytes. For example, if I'm writing B1 equal to byte array, so this will create one empty. If I'm writing print B1, So this is a byte array with what here? Empty. No bytes in that. Okay. If I'm writing B2 equal to byte array, I'm creating a byte array with some 10 I have given. 10 means nothing but how many bytes? 10 bytes. So this byte array is created with how many bytes here? 10 bytes. But these are empty bytes or not? Yes. And these bytes are represented in which format? Hexadecimal format. So B3 equal to byte array. So B3 equal to byte array of, I just use iterable. I can use iterable for creating this byte array. Now this byte array is created with how many bytes here? 4 bytes. That is 65, 66, 67, and one more is what? 68. So byte array is mutable. Okay. So I can create a byte array. I can create a byte array from existing byte array. Now this is creating byte array from existing byte array. Byte array is a mutable. Now whatever operations are there in the list. So I'm saying B5 dot append. So I'm trying to say B5 dot append 65 and B5 dot append. What is that here? 66 and B5 dot append. What you are trying to append here? 67. And if I say print B5, now this byte array is having how many bytes? 3 bytes. So the first one is A, second one is B, and third one is a C. So how many bytes are there inside this byte array? 3 bytes are there. One is A and second one is B, and third one is what? C. Just to try to understand this. So how can you work with the byte array here? Okay. So byte array is a mutable, but whereas bytes object is a immutable. Even you can remove it. I can say B5 dot remove. B5 dot remove. Which one you want to remove? 65. Now is it 65 is removed from byte array or not? Yes. So 65 is nothing but what here? A. Okay, that is removed from which one? Byte array. So remaining how many bytes are there in byte array? 2 bytes are there. One is a B and one more is what? C. So the number of bytes which are there in byte array is one is a B and one more is what here? C. So I'm saying no, this is just to understand how to create byte array. But we'll see this once we move to the files. Okay, and once we move to the files and networking. Okay, we'll talk about how to work with these bytes. But now, just to try to understand what is a bytes. Bytes is nothing but collection of bytes. So where you represent data in which format? 1 byte format. Where you represent the data in which format? 1 byte format. That is done by using which one? Bytes. Now these are collections. So when you're working with a collection data types, I said collection data types are classified into 3. One is what here? Sequences. And second one is what here? Sets. And third one is which one? Mappings. So sequences are, so list is there, tuple is there. So list, tuple, string. Okay, fourth one is a range, and fifth one is a bytes, and sixth one is what here? Byte array. Okay, now this is what we have seen. And when it comes to the sets, how many sets are there? 2. One is a set and one more is a frozen set. How many sets are there? 2. One is a set and one more is frozen set. As a part of mapping, there is only one mapping. And what is in mapping? Dictionaries. Okay. So as a Python developer, you must know all this. Okay, you must know all these collection types. And collection types are classified into 3 categories. The first category is a sequences. Second category is a sets. And third category is what here? Mappings. Okay, sequences are like list, tuple, string, range, bytes, and one more is a byte array. Now sets are classified into 2. One is a set and one more is a frozen set. So there is a different mappings out there, and within that there is one mapping collection called which one? Dictionaries. Okay, now next we'll move to another chapter here. Okay, so after this we'll just go to the next chapter, and what is the next chapter is functions. Okay, next chapter is what here? Functions. Functions chapter is there. How to work with the functions here? Okay, how can you work with the functions? So after dictionaries, but even though we have seen, but in your syllabus you don't have bytes and bytes array. But even though I said what is a bytes and bytes array, so all these things we have seen. Now coming to which part here? Functions. So this is a functions here. Then how to work with the functions, and without knowing functions, you cannot understand which concepts here? Object oriented. Okay, yes. So let us talk about how to work with the functions. But before talking about functions, okay, before talking about functions, so let me tell you about Python is a, okay, small introduction. Python is a which language? Python is which language? Multi-paradigm. Python is a multi-paradigm. What is Python? Is a multi-paradigm programming, multi-paradigm programming language. Python is which language here? Multi-paradigm programming language. So in Python programming is done. In Python programming is done using different. Okay, in Python programming is done using different programming. Okay, approaches are what is that? Concepts. Okay, how you write the programs in Python using different programming approaches, because as you know, a paradigm, a programming paradigm defines what a programming paradigm defines. Programming paradigm defines set of rules and what? Regulations. A programming paradigm defines set of rules and regulations for organizing of, okay, for organizing of data and what is that? Instructions. A programming paradigm defines set of rules and regulations for organizing of data and instructions. Okay. So in Python, you can write the programs. How you can write the programs? By organizing all the instructions in which order? Sequential order. So this is called as monolithic programming. So where you try to organize everything one by one. So till now, how we did, we try to organize all the instructions in which order? Sequential order, one by one. So there is a problem in this approach. This is actually called as which one? Okay, actually this is called as which one? Unstructured. Okay, this is called as which programming style? Unstructured programming. This is called as which programming style? This programming style is called which one? Unstructured. This is called as which one? Unstructured. When you're saying unstructured, how you are organizing instructions in unstructured, in which order here? Sequential order. You are organizing everything in which order? Sequential order. So there is a problem when you organize these instructions in which order? Sequential order. What is the problem in organizing the instructions in sequential order? For example, assume that, assume that I want to write a program to print like this. I want to draw first one line. And then I want to print a message Python. Then again, I want to draw one line. Then I want to print one message called programming. Then again, I want to draw one line. And then I want to print one message here, language. And again, I want to draw one more line. So I want this output. Okay, now here I try to draw how many lines here? One, okay, two and three, and one more is what? Four. What I'm doing is for drawing the line, assume that for drawing the line, I'm trying to write one for loop. Okay, for in range of some 20. This for loop is executed how many times? 20 times. And then I'm saying print. What I'm printing here? Star. It means this star is repeated how many times? 20 times. The star is repeated how many times here? 20 times. But will it print this star in the same line or in the new line? Same line. After that, I try to insert one new line. Okay. Yes. Now after printing a star 20 times, it will insert one new line. Then after that, I'm displaying one message. What is the message I'm displaying? Python. I displayed one message called Python. So after printing a Python, again I want to draw which one? Line. Again I want to draw the line. After displaying the Python, I want to draw again one more line. So what will I do? Again I repeat. For I in range of which one? 20. For I in range of 20, what you are trying to repeat here? Star. So you are repeating star how many times? Again 20 times. Then after printing stars, again I want to print which one? One message. What is that message? Programming. I want to print a message called programming. After printing a programming, again I want to draw which one? Line. Then for drawing the line, again I'm writing for I in range of 20. For I in range of 20, I just write print star. Okay, print star. How many times I print this star? 20 times. After printing that, again I want to print a message. What is that message? Language. So after printing a message language, I want to draw again what? Line. To draw the line again, I'm saying for I in okay, range of 20. Okay, print. What you are printing here? Star. How many times you are repeating this star? 20 times. And then you insert one new line. Now, if you see this code, right? If you see this code, okay. So what do you see in this code here? In this program, what happened here? What happened in this code? Some problem is there in this code. What is the problem is there? What problem is there in this code? Tell me here. What is the problem in this code? So there is some problem is there in this code. Some problem is there in this code. So what is that problem you find in this code? Yes. Yes, Subrat. Yes. Same work we have to repeat it. Same work we are repeating. Same code you are writing number of times, right? For example, if you see this code here, whenever you want to draw the line, suppose if I want to draw 100 lines, the size of the program is increased, right? Now see here, whenever I want to draw the line, I'm repeating the same code again and I'm repeating the same code again and again. I'm repeating the same code again and again. Why? Because I want to draw how many lines here? 1, 2, 3, and 4. So to draw each time one line, I'm writing some code here. To draw one line, I'm writing some code here, right? So this is a code for drawing the line. If I want to draw some 10 lines, I have to repeat this code how many times? 10 times. Then what will happen? The size of the program increase. If the size of the program increase, what will happen? It occupies more space. If the size of the program increase, it occupies more space. If it is occupying more space, then it will take a lot of time. It will take a lot of time. But I want to write this code how many times here? Only one time. But I want to use how many times? Number of times. I want to write this code how many times? Only one time, but I want to use the code how many times? Number of times. Then what do you do it? Whatever repeated code is there, whatever repeated code is there, whatever repeated code is there, and this repeated code you put inside one. This repeated code you put inside one, a small program. This repeated code you put inside one small program. And what is a small program here is, okay, you put this repeated code within one small program. And what is that small program here is function. What is a small program here? Function. So what is the name of my function here? Draw line. What is the name of the function here? Draw line is a function. So because function name is user defined. So function name is user defined, right? What is the name of my function here? Draw line. Draw line is the name of the function. Draw line is the name of the function by using which what you're trying to do, you're trying to draw the line. So how many times this code is written? Only one time, and you can able to use in your program how many times? Number of times. You don't require to write this code again and you don't require to write this code again and again. You write this code into one small program. You write this code into one small program, and what is the name of that program? Draw line. So whenever I want to draw the line, I just call one function. What is the name of that? Draw line. What is the name of that function? Draw line. What is the name of that function? Draw line. What is the name of the function? Draw line. But how many times the code is written? How many times the code is written? Only one time. And how many times it is used? How many times the code is written? Only one time. But how many times it is used? Number of times. Number of times. Now it means functions reduce the size of the functions will reduce the size of the program. By reducing the size of the program, it increase what? Efficiency. And functions avoids the repeated code. Functions avoids which one? Repeated code. Instead of writing the same code again and again, you are writing that code how many times? Only one time. And you are using that how many times? Number of times. Not only that, functions provides modularity. Modularity means, for example, I want to develop a calculator. I want to develop a calculator. Okay, now what I want is I want to develop a calculator. So calculator will have so many functions. Calculator is having a function called which one? Add. Calculator is having a function called which one? Sub. Calculator is having a function called multiply. Calculator is having a function called division. Calculator is having function called, okay, some all mathematical functions will be there or not. Yes, but each one you divide into what? Small program. And what is a small program here? Function. Suppose if any changes to be done in add, you do changes only in which function? Add function, without doing any changes in multiply, without doing any changes in subtract, without doing any changes in what? Division. So maintaining your code also becomes what? Easy. By dividing your program into what? Small pieces. You are dividing your program into what? Your small pieces, so that you can work with multiple functions. Or suppose assume that two people are developing calculator. So one person will develop some functions of calculator, other person will develop some functions of which one? Calculator. It means one project parallelly work how many people? More than one. Because this code is divided into what? This code is divided into what? Number of functions. So more than one person can work simultaneously on the same project or not? Yes, because this project functionality is divided into what? Number of functions. So one person will develop some functions, the other person will develop other functions, and this both the functions will be integrated and call in one program, right? So what is a function here? What is a function here is now what is a function here is what is, okay, what is function is, okay, But there are different programming approaches out there. What is it here? Unstructured programming. Unstructured programming, and one more is which one? Procedural oriented programming, which is called as POP. And there is object oriented programming, which is called OOP. So unstructured programming, procedural oriented programming, object oriented programming. Unstructured programming, procedural oriented programming, and one more is which one? Object oriented programming. So what is a function here is, okay, so this is a problem with the unstructured here. So this is what will happen in unstructured. So where there is a code redundancy will be there. Okay, code redundancy will be there in unstructured. So there is a code redundancy. Okay, to avoid this, we'll go for, there is a code redundancy will be there in unstructured. So what is a function is? So there is unstructured, there is a procedural, and there is object oriented. But this kind of programming style is called which one? Procedural oriented. This is called as which one? Procedural oriented. This is called which programming here? Procedural oriented programming. So what do you do in procedural oriented programming? You divide your programming instructions into a small pieces, and each piece of program is called one function. Each piece of program is called as which one? One function. So there is a function called add. There is a function called sub. There is a function called which one? Multiply. So here you'll have all the instructions belongs to. Here you have all the instructions belongs to which one? Addition. And here you have all the instructions belongs to subtraction. Here you have all the instructions belongs to which one? Multiply. So it means it is divided into a number of pieces, and each piece of code you call it as which one? Function. Each piece of code is called as which one? Function, right? So the question comes here is, what is a function is, and what is the need of writing a function is. So what is a function? A function is a small program. Function is a small program within program. What is a function? Is a small program within the program. A function is a self-contained block. A function is a self-contained block which contain what it contains? Some set of instructions to perform some operation. A function is a self-contained block which contains some set of instructions to perform some operation. A function is, you can say a function is which block? Named block. What is a function? A function is a named block. Named block means a block which is having some name. And why we are writing a function? What is the advantage? What is the advantage? What is the advantage of functions? Okay, what is the advantage of functions? First one is modularity. What is the first one? Modularity. So what is the first one? Modularity. Modularity is nothing but dividing. Modularity is as in nothing but dividing. What you are dividing? Instructions. You are dividing instructions according to their operations, according to their operations into small pieces, dividing instructions according to their operations. For example, you are developing one ATM application. ATM is there. What is this application here? ATM application. In ATM application, there is so many functions will be there. Withdraw will be there, check balance will be there, mini statement will be there, change of pin will be there. So there is one function. What is the name of this function? Check balance. What is the name of this function? Mini statement. What is the name of this function? Withdraw. What is the name of this function? Some other operation like some XYZ. It means this ATM application functionality I divided into what small pieces. I divided this ATM application functionality into a small pieces, and each piece is called as which one here? Function. I divided this ATM application. I divided this ATM application functionality. I divided this ATM application functionality into what? Small pieces, and each small piece of code is called as which one here? Function. So what is the advantage of function? Modularity. So dividing, modularity is nothing but dividing it here, right? And second one is reusability. Okay, reusability. Okay, reusability is there. So functions are reusable. Functions are what here? Reusable programs. Functions are reusable programs. Reusable program. Once function is created, it can be used one or more than one time. Okay, it can be used one or more than one time. The next one is readability. Okay, readability is that means easy to what here? Understand. I can easily identify this is a code belongs to withdraw. This is a code belongs to what? Deposit. This is a code belongs to what? Check balance. This is a code belongs to add. This is a code belongs to what? Sub. Because you are trying to put that code within one block. So add related instructions you put in which block? Add block. Sub related instructions you put in which block? Sub block. But each block is here what? Function. Each block is what here? Function, right? So readability means easy to understand. You can easily understand this code belongs to this. So functions are reusable programs. Once the function is created, it can be used one or more than one time. Modularity, dividing instructions according to their operations into small pieces. Small pieces. Okay. And not only that, readability, and one more is what? Efficiency. Okay, one more is efficiency. So functions increase the efficiency of the functions increase the efficiency of which one? Program. Functions increase the efficiency of the program. But how functions increase the efficiency of the program? By decreasing what? Size. How functions increase the efficiency of the program? By decreasing the size of the program. Because you are not writing the same code again and again. Okay. So functions increase the efficiency of the program. It means functions increase the efficiency of the program by decreasing the size. Because you are avoiding redundant code. That is called as reusability. Writing the code once and using it how many times? Number of times. Now this is the advantage of writing which one? Functions. And functions are building blocks. Functions are building blocks of which programming style it is? Procedural oriented programming. Like C language. Okay. C is which language? Procedural oriented programming language. C is which language? Procedural oriented programming language. What is a C? C is a procedural oriented programming language. C is a procedural oriented programming language. So how you write the programs in C? Everything you write inside what here? Functions only. Without functions, you cannot write a program. And these functions are two types. Functions are two types here. One is predefined functions. One is predefined functions. How many types of functions are there? Two types. One is a predefined functions and second one is user defined functions. Functions are two types. One is a predefined functions and second one is user defined functions. Predefined functions and one more is user defined functions. Two types of functions are there. One is predefined and one more is a user defined. So there is a predefined functions. Predefined means these are the functions provided by Python. Okay, so the functions provided by the functions which are provided by Python programming language. Python programming language are called which functions here? Predefined function. Like example is till now we've seen some functions: print function, input function, length function, sort function, octal function, hexa function. Okay, and what is that? Binary function, string function, list function. All these are predefined or user defined. Predefined. So these are the functions provided by whom? Python. The functions which are provided by Python are called which functions here? Predefined functions or pre-written functions. Okay, predefined functions or pre-written functions. The functions provided by Python. The functions provided by Python are called predefined functions or pre-written functions. Right. Yes, 1 minute. Right. So this is how you are trying to work with this, right? Yes. So these are predefined functions. The functions which are written by whatever functions which are written by whatever functions written by are provided by Python language. So those are called predefined functions. And these predefined functions are also called which functions? Library functions. These are which functions? Library functions. Integer, print, input, length, sort. So whatever functions we have seen till now, all those are which functions? Library functions. But the functions which are written by the programmer, the functions which are written by whom? Programmer. The functions written by the programmer are called which functions? User defined functions. Functions written by who? Programmer are called which functions? User defined functions. Okay, these are the functions which are specific to application. Application specific functions. Application specific functions are also called which functions? User defined functions. Application specific functions. It means, for example, you may write some functions like deposit belongs to which application? Banking. So no. Okay. Deposit is a function belongs to which application? Banking. I may write a function called mean. I may write a function called median. I may write a function called what? Mode. These are the functions belongs to what? Statistics. So when existing functions doesn't fulfill your requirement, then you build your own functions. You build your own functions, and that functions you call it as which one? User defined functions. So functions written by programmer are called which functions? User defined functions. And these functions are application specific. Okay. Then how to write a function? How to write a function? How to write? How to write? How to write a function? Why you are writing a function? You are writing a function to perform operation. Why you are writing a function? To perform operation. Why you are writing a function? To achieve modularity, reusability, readability, as well as what? Efficiency. You are writing a function to achieve modularity, reusability, readability, and efficiency. And you are writing a function to perform operation. Means you are organizing instructions by dividing into small pieces, and a small piece of code is called as which one? Function. So how to write function? How to write function in Python? So function is divided. Function is divided into how many parts here? Two parts. Function is divided into two parts. One is writing function. One is writing function, and second one is what? Invoking function or calling function. Okay, invoking function or calling function or executing function. So writing function is nothing but defining function. Defining functions. Now, suppose if you are saying predefined functions, who's written predefined functions? Python people. Then who's executing? Who's executing? Python programmer. So Python programmer want to input, then he just execute which function? Input function. Python programmer want to print, then he's executing which function? Print function. So function is divided into how many parts here? Two. One is writing function and one more is calling function. You write a function, but until unless you don't execute, is it that function is executed or no? So Python is provided so many functions like print function, input, maximum, minimum. So many functions are there, but whichever function you want, you just call it. You just call it or what? Execute it. By just writing the function will not be executed, right? So function is divided into how many parts here? Two parts. One is writing function or defining function, and second one is invoking function or calling the function or executing function. Then how to write a function? Defining function. Syntax of defining function. Syntax of defining function. How you write a function? Why you are writing a function? To perform operation, right? And the function is defined by using one keyword called def, which is called as def, right? Okay, so function is defined. Function is defined using one keyword. One keyword is there. And what is the name of the keyword? Def. Using this keyword def, you write the function. How you write the function? By using one keyword. What is the name of the keyword you are using? Def is a keyword which you are using to write one function. Okay, so def, see here how you are writing def, and it followed by def, it followed by what name? DEF, it followed by what name? Function name. Function name is a predefined or user defined? User defined. And all user defined words are called identifiers or not? Yes. So here function name is what? Identifier. What is the function name here? Identifier. So DEF, it followed by what name? Function name. DEF, it followed by function name, and it followed by what here? Arguments. It followed by arguments. You call it as arguments, or you call it as which one? Parameters. Now you may write a function with parameters, means input. You may write a function with inputs, or you may write a function without inputs. And function is a block. And how you write a block? Block is begin with what here? Colon. How the block is begin with a colon, and then you write a block by giving indentation, then include number of statements. That is statement 1, statement 2, and there's one more statement called statement 3. So how many statements are included within the function? 3 statements are included, right? But when you are saying a block, okay, when you are saying it is a block means, is it block is having only one statement? No. So block should not be empty. Empty blocks are allowed or not allowed? Not allowed. Empty blocks are not allowed. Empty blocks are not allowed, right? A block must have at least one. A block must have at least one statement. A block must have at least one statement, right? If you are trying to write an empty block, so is it Python is allowed or not allowed? Not allowed. Empty blocks are not allowed, right? Yes. So this is writing the function. So a function can be defined. A function can be defined with okay. A function can be defined, okay, with arguments or parameters. So without arguments or what? Parameters. Okay, with a written value, or without what here? Written value. A function can be defined with arguments or with parameters, or you can write without arguments or parameters, and with written value or without written value. Okay. So with written value or without written value, a function can be defined. A function can be defined with arguments or without arguments or parameters, or with written value or without written value. So note, function is a block, and block should not be empty. If you want to write an empty block, how you write empty blocks in Python? Include one statement called which one? Pass. How you write empty blocks in Python? By including one statement. And what is a statement you include? Pass. Pass means do any operation or no operation? No operation. Okay, pass means are you doing any operation or no operation? No operation. Okay, so parameters are nothing but variables. Now here, these variables will receive some value. You want to give some input to the value, right? You want to give some input to the function. If you want to give the input to the function, you write a function with which one? Arguments. If you don't want to give the input to the function, then you write a function without arguments. With arguments and without arguments. Because, for example, there is a function is there. For example, there is a function, and what is the name of the function? ORD. Is it ORD is a predefined or user defined? Predefined. ORD of A. What is ASCII value of A? 65. Are you given input or not? Yes. What is the input given to the ORD? A. So this input, when I can give the input, if the function is having receiver, okay, receivers, that receivers are nothing but what here? Arguments. You are giving some input to which function? ORD function. Okay, these inputs are received by which one? Arguments. Or these inputs are received by which one? Parameters. For example, There's a function called max, but it is given error or not? Yes. So type error, max accepted at least one argument. At least one argument, because to find the max, is it required some input or not? Yes. How many inputs it required? At least one. I'll say max 10 comma 20. How many inputs are given? 2 inputs. Means max required input to find out which one maximum. What is the max of 10 comma 20? 20. So max 10 comma 20 is what here? 20. So required input, when function required input right now, then you write that function with, if the function required input, then you write a function with what? Arguments. If the function doesn't require input, then you write a function without arguments. So with the arguments or without the arguments. Arguments are nothing but variables. What is the arguments here? Variables which receives values, right? Then I'll tell you like how to write a function and how to call the function and what are the different types of arguments or parameters and all the things, but not today, but I'll tell you tomorrow, right? So today we'll stop it here and tomorrow we'll continue with the functions, right? So thank you. We'll see tomorrow this, right? Okay.